Let's try to calculate the angle between the two planes. Now, to find the angle between two planes, it's quite easy. What we do is assume that you have a plane. So, first we'll start with the x, y, and z axis. Okay. So, you have x, y, z axis. Now, let's assume that you have one plane, which is something like this. Now, for this particular plane, we can draw a normal like this, correct? Let's call this as n1. This is a normal. Remember, normal is always perpendicular to the plane. In the sense, if this is the normal, sorry, if this is the plane, then this is going to be the normal, perpendicular. Now, let's assume that we have one more plane. Okay. So, let's assume that you have one more plane, maybe something like this. Fine. Now, for this one, we are going to draw a perpendicular in the sense, let's call this as n2. This is one more. Now, what we are trying to calculate, we are trying to calculate the angle between the two planes, what we can call as theta. Fine. That means here, see, practically speaking, assume that this is one plane. Assume that this is one more plane. These two planes are intersecting. What is the angle between the planes? Now, angle between the planes is nothing but the angle between the normals. Because for a plane, this is the normal. Correct? And the same thing is going to be there for another plane. That means we have a normal for another plane. The angle between the planes is the same as the angle between the normals. So, the angle between the normal is theta. Now, if this is theta, see n1 and n2 are two vectors, isn't it? And angle between two vectors, how do we take? We take the dot product. That means here cos theta is equal to n1 dot n2 divided by, if you remember, it's a dot b by mod a into mod b, right? So, mod of n1 into mod of n2. This gives us cos theta, the angle between the two normal vectors n1 and n2. And not only that, the angle between the two normal vectors is also the angle between the planes. Clear? So, cos theta is n1 dot n2 by mod of n1 into mod of n2. Now, this particular formula what we have is with respect to the vector form of the planes. What do we have in the Cartesian form? Now, for the Cartesian form, we'll consider two planes. Say you have a1x plus b1y plus c1z plus d1 is equal to 0. This is the first plane. Say pi 1 is this. Now, second plane pi 2 will be a2x plus b2y plus c2z plus d2 is equal to 0. This is the second plane. Now, the angle between the two planes is nothing but same dot product, correct? So, this way if you do it, then we'll get cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Of course, modulus of this. This is going to give us the angle between the two planes in the vector form or in the Cartesian form. Fair enough? Now remember, angle between the two planes is the same as angle between the two normals corresponding to the plane. Whatever it is, however it is, it's always the angle between the normal. Fair enough? So this is how we get the formula. Now in the next video, what if we have a line and a plane? How do we figure out the angle between a line and a plane? We'll look into that in the next video.